Hey guys, so now we want to look at a different way to organize data besides dot plots. So the next type of plot we're going to look at is a histogram. A histogram looks very similar to a bar model, but what a histogram is a little bit different, and it shows frequency instead of individual data points. So college students were asked how well they did on their first statistics exam, and then here's their scores. So a histogram is a bar style data display showing frequency of data measured over intervals, rather than showing like each individual data value. So each interval with width must be the same. So I can't talk about like from 5 to 10 and then 10 to 50. Those intervals have to be consistent. And remember, we always want to title our graph. And we also want to label both axes also. So we need to choose an appropriate scale. We usually use histograms when we're talking about large data and continuous data, because we can contain that data within a specific interval instead of having to do individual data points. And an interval is just a range of values. So if we were to take this data of our statistics exam, let's create a histogram. So here's my histogram. I obviously want to make the exact same interval. So the lowest score here, it looks like, is a 62. So I'm going to make my lowest point on my histogram 60. This first piece of data is going to go from 60 to 70, 70 to 80, 80 to 90, 90 to 100. So here are my data points, and then this is going to go by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So my first piece is from 60 to 69.99999. So how many people in this class got somewhere between a 60 and a 69? Well, that looks like 1, 2 people. So I'm going to make my bar, and it's going to go up to 2 from between 60 and 70. In the 70s, it looks like 1, 2, 3, 4, 5 people. So I'm going to make my bar go all the way up to 5. And I just like to color it in because I think it looks pretty. From 80 to 90, or 89.99999, is 3 people. From 90 to 100, 1, 2, 3, 4, 5. And then we actually want to make another one, 100 to 110. Looks like 2 people got 100 to 110. So that's what a histogram is. So I can't, if I were not given the specific data points and I was just given the histogram, I couldn't necessarily tell what each person got, but I could tell how many people scored between a certain amount. 2 people scored between a 60 and a 70, 5 people scored between a 70 and an 80, and so on. So that's how histograms are a little bit useful. So here's another example. So those same students from our first example were also asked how long in minutes it took them to complete the exam. The data is shown below. So we want to construct a histogram to represent this data. So now we're doing study hour or study minutes instead of grade. Okay, so to make the scale in the histogram, I always want to look at what the smallest data and the largest is. It looks like the smallest amount is 32.3 minutes, and the largest data was around 71.3 minutes. So we'll say our smallest data is 30. I'll do 30 to 40, 40 to 50, 50 to 60, 60 to 70, and 70 to 80. So if we're looking at 30s, this person studied 32.3 minutes, and this person studied 35.8 minutes. Again, I'll count up the side by 1, up the y-axis. So 2 people studied between 30 and 40 minutes. Between 40 and 50, 1, 2, 3, 4, 5, 6, 7 people. That's a lot. Between 50 and 60 minutes, looks like I messed up. I think it's just 6. Let me go back. Sorry, I counted that one wrong. Let me erase it. That one should just be 6 people, not 7. And then 50 was 1, 2, I think 2 people for 50, between 50 and 60. Between 60 and 70, 1, 2, 3 people. And then between 70 and 80, 1, 2, 3 people. That would be an example of the histogram for the amount of minutes studying for the same group. All right, so determine the sets where it would be better to use a histogram instead of a dot plot. So the first one set, and select all that applies. So that means we're at least going to have 2 answers. So the average daily temperatures for Albany, New York over the year. That's a lot of data, 365 pieces of data. I wouldn't necessarily want to do that in a dot plot. And you could have 0.1 degrees, 0.2 degrees, 0.3 degrees. So we're going to say that that would be better used for a histogram. Daily temperatures in Albany over a month. That's a little bit smaller. That would only be like 20, 29, 30, 31 pieces of data. So I'm going to say that that would be better with a dot plot. The results of rolling 2 dice over and over. Those are whole numbers, so I'm going to say that that would be better used as a dot plot. Height of a high school football player statewide. That's a lot of football players, so I'm going to say histogram there. Finishing times of 125 randomly selected athletes for a race. Again, I would probably say histogram because that's a lot of data to have to include in a dot plot. Okay, last question. So here are the frequency of total points scored by a team in 20 games for the local men's basketball season. So let's create our histogram. So it looks like the lowest number here is maybe 45, I think. Yeah, so we're going to count by 5. So let's do 45, 50, 55, 60, 65, 70. Oh, I didn't see that 89 here. Let's change that scale. Let's go by tens, I guess. So 40 to 50, then 60, 70, 80, and 90. So how many times did they score between 40 and 50 points? 1, 2, 3. 3 times. So we'll go up by ones because we're just counting number of games. So 3 times they scored between 40 and 50. What about between 50 and 60? 1, 2, 3, 4, 5, 6, 7. 7 times. 1, 2, 3, 4, 5, 6, 7. Between 50 and 60. Between 60 and 70. 1, 2, 3, 4, 5, 6, 7 is 7 again. And then 70 would be 2 times between 70 and 80. And they scored over 80 points, specifically 89 points. It's a lot in a basketball game for a local team. They scored that 1 time. All right, so this would be how you would do a histogram. Again, it's better for continuous data or data that has a lot of data points. So if you have any questions, let me know, and I look forward to hearing from you guys. Bye.